Hi, everyone. This is Sebastian Traeger, Managing Director at Reliability Center, and welcome back to another Reliability 4.0 episode. As always, we're on a mission to help make the world a more reliable place. And we do that as a company through root cause analysis. Our guests also do that through different things, and that's what we want to learn about. And today, we are thrilled to be joined by Kim Stalder. Kim is the Asset Reliability Team Leader at Schreiber Foods. And we are thrilled to have you on. Kim, thank you so much for joining us.
Thank you, Sebastian. It's good to be here.
Well, tell us a little bit about first just Schreiber Foods. Tell us a little bit about that, and then your role there as well.
Okay. Schreiber Foods is not very well known to the public. However, we are the largest privately owned dairy manufacturing company in the world and have plants all over the world. There's a good chance that if you eat any cheese or yogurt or cream cheese or natural cheese, that you've probably had some of our products.
I eat all those cheeses. So what's the kind of most well-known brand that people may have heard of that you all supply or provide for?
Some of those I'm not really at liberty to say, but
Oh,
let's
okay.
just say if you eat at a lot of restaurants or you shop and purchase store brand products, there's a good chance that it came from Schreiber Foods.
Excellent. Well, good. So you're being a blessing to all of us every day without us even knowing it. So thank you. How did you come to be a part of kind of a reliability engineering world? What's your kind of origin story to get there?
Oh, yeah, I took a interesting path to get there. I started out as a quality technician, lab tech, testing yogurt products and that sort of thing. And when we were doing root cause analysis on issues that we had from a quality perspective, contaminations, that sort of thing, I spent a lot of time working with the maintenance techs and taking apart machines and really just got to enjoy the process. Also being in that position, I was able to see most everything in a facility from incoming milk through the culture process and then refrigeration and shipping things out. My background, educational background, is in food and biomaterials engineering. So I had that engineering background and interest and spent a lot of time on a farm doing things with my hands and kind of put the two together and ended up eventually migrating into the world of maintenance and reliability.
Okay, that's great. That's a neat story. I do have a follow-up. What's so as a yogurt tester, what is that? Are you literally like got spoons of yogurt and you're just eat like what's that look like?
Yeah, that's a good question. So there were times where literally we had spoons of yogurt and we were testing it, doing flavor profiles and looking at the color and the texture. We also used instrumentation. So some of the things apply directly to reliability. We did viscosities on our product, so you could cross that over to oil analysis and looking at viscosities on oil. There were several different things that we did. Looked under the microscope at stuff that
Huh,
crosses over to reliability if you're looking for defects in a bearing or something like that. Sometimes it takes magnification. Just looking at different things, but
fascinating.
similar tools.
Okay, great. And before we kind of dive into like more aspects of your job, I just like to ask, one thing you like to do outside of your work or family, just something you just want to share more on a personal note with folks.
Sure. Yeah, I really enjoy riding and racing dirt bikes, off-road motorcycles, motocross, cross country, and that sort of thing. And that gets my hands dirty every once in a while with rebuilds and that type of thing as well. It keeps me up to speed on my torques and using proper tools and looking at tolerances. So it kind of
Very
marries
cool.
up to work, but it's also good stress relief and a lot of fun.
That's pretty neat. What a neat hobby. Fun that you get to do that. Heading back into the work front. So as in your role, what are, when you think of KPIs, how do you organize your KPIs for the business? How do you think about that?
Yeah, that's a good question. And I um, just got queued up for this. I just read an article on metrics and KPIs. So metrics tell us a story. They're measurements that we use to tell us what's going on. KPIs typically are key performance indicators that are better aligned to your company's objectives and that sort of thing. And there's leading and lagging. So um, when we use KPIs, we do have a list of industry standard metrics that we list, and we'll sometimes refer to them as KPIs. We're kind of all inclusive. At the same time, the ones that we focus on depend upon where we're at in our maintenance or reliability journey. So sometimes we start out with something simple like looking at the amount of technician hours we're capturing and seeing what prevents us from capturing the hours and putting the right tools in place so that we can get data into our system and then what that data looks like. So we look at that, we call it our CMMS is Oracle EAM. So we say EAM versus Kronos, and Kronos is our time system.
Okay.
That's one of the most simple. We don't publish that to the text because it's an easy one to cheat. But that gives us an indication if we're capturing our reliability, our reactive work as well as all the planned work.
Interesting. That's good. That is a good simple metric comparing two systems. On that, do you all have I always like to ask folks what the cost of downtime is for them. Do you all have kind of a standard cost of downtime that you work off of?
Oh, we don't, and that's one of the biggest frustrations we come across in our company. The other companies that I've worked for, we did have a good number that we could use. Our company is a little bit more challenging because of our products. In some cases, we can actually use the profitability. So there's a certain cost per pound that we make in true profit.
Okay.
That's not always used because sometimes we have additional availability on our assets, and so that wouldn't be a true number. So often we work with our financial leaders and some of the category leaders to figure out what we're going to use for an ROI or for calculating the cost of downtime.
And why? So just on a simple level, what is the complication with cost of downtime there? Why is that a difficult? Like even if there's different products, theoretically, you could say, well, for each product.
Yeah. So if theoretically, if your assets are fully utilized, then any minute of downtime is lost profit. In our case, we have certain categories that we don't fill the lines or we've got excess capacity and we can't sell that.
Okay.
So there's not a reason to run that. And that's when it's not a good idea to use the profitability to calculate the downtime. We have other products that we can't produce enough of.
Right.
And in those cases, it does make sense. I think our history has been that we've bounced back and forth and sometimes miscalculated what the true ROI of a project was, and that's why there's a little bit of sensitivity, and that's why it varies a little bit um, depending upon what our supply and demand is and our
Good.
asset availability.
Makes sense. It's good. In terms of top priorities or challenges you're facing now, what are some of those kind of biggest things you're looking to tackle right now?
Yeah, so we're focusing on a few pretty elementary or foundational items. One is looking at um, using the 101s of text. So a lot of us in the industry probably recognize that there's been a big loss of the baby boomers and that sort of thing. So with that, a lot of the millwright skills and the precision setup type skills have gone away. A lot of the hands-on mechanical skills have gone away. And there's been a gap in that education and a gap in the workforce. So we're seeing a little bit of that depleted. So that's one of our areas that we're really focusing on is getting back to the basics, like using a torque wrench, learning how to align our rotational devices and measure vibration on them to see, simply put, if it ain't shaking, it ain't breaking. And so our goal is to teach our technicians and our operators that if they see something that's shaking, let us know so that we can keep it from breaking.
Right.
And if we're making a repair, try to do it once, do it right. So that's a huge one, skills improvement. Um, and then another one that's just foundational for getting your EAM system going and taking a lot of the emotion out of a reactive environment is asset criticality
Hmm.
and doing a review of that to make sure that it's still accurate and that the right parties were engaged, that all of our operations leaders and everyone understand what it is and how to use it. It makes it easier to prioritize work and not have to fight all the fires at once or to be able to plug away at something that's more important, make a bigger
Good.
impact with the little bit of resources you have.
That's good. I've heard that the first one, especially, I've heard kind of lack of skilled workers are you all primarily kind of prioritizing the training of folks, or like even getting earlier in the process of like, hey, kids coming out of high school, let's almost create like some sort of a program?
Yeah, we're doing a combination of both. So our existing technicians, we have some classes that we go through. We've partnered with Reliability Solutions to do some of their essential craft skills training. A lot of that is very millwright orientated. And then secondly, we've partnered with a few of the local tech schools to try to do a sponsor scholar type deal where we'll help invest in the students' college, and in return, we just ask that they work for us for a couple of years. And while they're going to school, we offer some opportunities to get that hands-on experience
Hmm,
to connect the book learning and hands-on at school, but not in a production environment type thing.
that's good.
So
That's great.
yeah.
You mentioned earlier that you did kind of root cause analysis as part of the yogurt tasting. How does root cause analysis currently play into your current workflow? When is it being used? How essential is it? What are the results you're finding?
Yeah, that's a good question. We have a couple of trigger points. So we call our maintenance playbook a model, and essentially it's just that we've documented what it takes to be ISO 55000 compliant. We use trigger points in there, and we lower the water. So right now we look at any 8-hour downtime event, and collectively with our operations leadership and our process excellence team do root cause analysis on those items. Additionally, when we look at our reliability process, we have what's called a reliability improvement process that can be triggered off of those 8-hour downtime events. Eventually, we would like to get to the point where we're doing RCAs on 15-minute or greater downtime events,
Wow.
and then reliability improvement process on 20 minutes or greater. So if you try to
Okay.
start there, there's just too much to try to take on, and it's unrealistic. So we started just getting people used to the process, and those
It's
were our
good.
trigger points that we've got right now.
It's great. Well, and that's a good goal to get to that stage um, at some point. Well, I could probably ask you more about that, but I want to turn to innovation and just kind of where you are seeing innovation, whether it's AI or obviously that's the big buzzword. IoT was a buzzword a couple of years ago. Where are you seeing innovation in your world, and how what is your company maybe taking on? Obviously, some of that's going to be confidential, but that you are allowed to share with others to spur their thinking.
Sure. I think a couple of areas that we could share are taking vibration analysis. Excuse me. So continuous monitoring to a different level. So vibration analysis has been around for decades, right? You could do routes. Paper industry has been using it for years and years. Oil and gas has. We have brought that in, and we've been using continuous monitoring to help us identify both process related defects as well as wear on our machines and alignment or looseness and where lubrication issues and that sort of thing. Um, for us, we've concentrated and worked with a company. We've partnered with a company to start being able to detect when we need to clean our separators or when they
Hmm,
haven't been cleaned. So a separator is essentially like a centrifuge. We're
okay.
separating two different products, and they're very critical assets for us. If we lose one, then it takes down anywhere from 25% to 30% of one of our processes. So
Wow.
it's pretty
Okay.
critical, and we're getting pretty good at being able to detect when an asset needs to be cleaned, or when it didn't get cleaned, as well as now we're taking the next step in identifying single components like a gear or a specific bearing that has some wear on it and needs to be addressed, versus doing a full rebuild. So normally you would do a full rebuild or either a full rebuild or a half rebuild, and that costs quite a bit of money and takes 8 to 10 hours to do. So by doing the continuous monitoring, we're able to see the defects and just correct that instead of taking the separator out of service on a time-based frequency.
And so just to put that in perspective, and that's fascinating. So, change a component as opposed to like a full rebuild. just taking that scenario, and I know it's going to differ based on the line, but what type of cost savings is there just in that one improvement?
Yeah, that's a great question. And fortunately, we've got some really good reliability resources that have tracked this. So our first year, we were able to see about $200,000 in reduction just on one fleet of separators, and we were learning during that time. So the next year, if we look at a 3-year period, we're looking at about $350,000 and still continuing to improve the process and continuing to learn and add things like oil analysis to complement the vibration analysis so
Right.
that we can see which component's wearing. Yeah.
That's great. I mean, that's a great example. It's just a very tangible one. It saves time. So, I mean, it saved the money. So 200 to 350,000. B, the time that was going to be spent doing a rebuild can now be reallocated to something else, right? And then C, it keeps the lineup longer. So
Yeah.
that's pretty incredible. That's
Yeah.
neat.
And then with the separator also from a yield loss perspective, they perform better. So we're not losing
Hmm.
the high dollar solids that we might otherwise. And that of course, if you're putting it into your production stream, you're getting that as a yield and throughput improvement as well.
It's great.
So
Well,
yeah.
Kim, it's been great talking to you about just how you got into the industry, what you're working on now, and some of the things in the future. Before we go, though, what's maybe something, rewind the clock on your own career or things you know now you wish you knew then, however you want to frame it, but just one piece of expertise that you'd want other reliability engineers to hear from you, just as an encouragement.
Yeah. So I'm seeing the culture change. So this may not apply to everyone, but a huge learning for me being in maintenance and when I went into maintenance and engineering was the faster you learn to partner with your operations leaders, the faster you start to enjoy your job.
Hmm.
That conflict. So yeah, you've got to maintain a budget and that sort of thing. But the reality is, you don't have a budget, you don't have a job, and neither do your techs if operations isn't performing well. So the sooner you can make that connection, I think the better. And then never stop learning.
Hmm.
Listen to the podcasts. Get on the webinars and that sort of thing, and just keep engaging your mind because a lot of the time you can connect some dots to come up with something like what we've done on the separators. We know that process, and there's other technical people that taught us some of the vibration analysis, oil analysis, and by putting those things together, that is being innovative, even though it's been around for decades.
Right.
The combination, you can come up with something that'll make a difference at your company and make you feel better about what you do every day.
That's great. Well, I like that how you just said, hey, I took two things that have been around a long time, but by applying them together, that's actually made a big difference. So that's a good word. So that's really helpful. Well, we've just thank you so much, Kim. We've had Kim Stalder on the podcast with us. She's the asset reliability team leader at Schreiber Foods. Thank you so much for your time. We really appreciate it. It's been just great having you here. And to all those listeners, this podcast, Reliability 4.0, is all about helping reliability engineers and really anybody just take the next steps to successfully doing your work. So we hope that you've learned something from this. Obviously, as a company, we try to contribute to that through helping people do RCAs, through training, through resources, through our software, Easy RCA. We hope if that's something you need, you'll check it out. Otherwise, we hope you've learned a lot today. And together, let's go forth and make the world a more reliable place. We'll see you on the next episode. Thanks so much.